So I think we'll just jump right in there and do a few more lecture slides. This is familiar. We spent a fair bit of time kind of talking about this side over here. Okay, so it's like a logic tree. So you start out with matter, and if it's a pure substance, then your choices are it could be an element or a compound. An element just are all the same atoms. Okay. And then compound is atoms joined together. Let no man put asunder, joined together. Atoms of different types of elements joined together chemically with chemical bonds. And then if you have two or more pure substances that are just physically tossed together, like you toss a salad, we're going to look at some examples of mixtures today. Okay, your choices are that those two pure substances could be well mixed, and it's a homogeneous mixture, or it could be chunky, and it's not the same throughout, your mixture. So we just keep talking about that. All right, so remember, a substance is a pure substance, so that was kind of on the left of our kind of map we looked at. So your options for pure substances are elements or compounds. The thing about both elements and compounds is you know what you got. So like if somebody says, I have a substance here and it's sulfur, you're like, oh, okay, I know all the atoms are sulfur atoms. If somebody says, I have a cup of liquid here and it's water, you're like, oh, okay, I know, I got H2O repeating units. Okay, so it has a definite composition. And we're going to talk, I think we'll get to it today, we're going to talk about what properties are, but it always behaves the same way, say the same properties. Now this is in contrast to a mixture. Okay, so we're going to see that mixtures, it's up to the author of the mixture, so to speak, as to kind of what percent of each type of pure substance they tend to physically combine. So with mixtures, you don't know what you have, unless somebody tells you. Okay, so a mixture, like I said, it's two or more pure substances that are just kind of tossed together and physically combined. They're physically stuck together. They're close to each other, those little pure substance molecules or atoms. Okay, but there's no chemical bond sticking them together. No chemical bond. And the cool thing about mixtures, okay, is that, I'll put both of these up here. The cool thing about mixtures is that it's kind of like, I know I hate to get sappy on you, but when you get married, there's a lot of different nuances and social things that happen when you get married. But when you join together, you should retain your own identity. That's what this slide says. You become a mixture of people, but you are still you and he is still him, or they are still them. Okay, so that's kind of what mixtures are. So we have a homogeneous mixture. To homogenize means to mix it really good. I kind of tease that you can take anything that's chunky, like a salad, like a tossed salad that has tomatoes and cucumbers and lettuce and onions, and it would be heterogeneous. But if you want to homogenize it, what could you do? You could just put it in the blender. Yep. It's kind of icky, but yeah, that would be a homogeneous mixture. But before you mixed it, it would be heterogeneous because you have your egg sitting there and your water, your oil, and your cake mix. Yep. Yep. Have you ever had one of those like chopped salads at Subway? It's kind of fun. The first time I had it, I'm like, what are you doing? It's like, okay. All right. So mixtures. Again, the substances in there retain their own identity. So, like, if you look at the whole Subway salad, even though they kind of chop, 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 I could look at the molecules and I would still find a tomato molecule, okay, unharmed, because even if they chop, they're not going to take the tomato molecule and break it down, okay, kind of icky. When you make a mixture, like I said, it's kind of up to the author to pick the ratio, okay. This is where I kind of talk about if you were going to make your Kool-Aid, like from unsweetened Kool-Aid little bag thing, you could, my daughter, when she makes it, instead of putting like 1 cup of sugar, she puts like 1.5 cups of sugar. So she can choose how to make her mixture. But the whole thing about Kool-Aid is those water molecules are still water molecules, the sugar molecules still sugar molecules, you know, and the Kool-Aid, you know. Okay. So, here we go. Which one looks chunky, A or B? How many people think B looks chunky? Yeah, the second one looks chunkier, so that would be a heterogeneous mixture. And this actually, you wouldn't even necessarily know this is a mixture per se. The yellow color gives it away. Actually, it's mostly water with a little bit of potassium chromate dissolved in it. I'm going to have to say this because it went through my mind. So, like, if we give a urine sample, because that's what that looks like to me. If you give a urine sample, do you guys buy that actually that's a mixture too? It's a mixture. It's water, and then it's got the other chemicals that are wastes of our body. How could you separate out the water from like a urine mixture?
A machine.
A machine? Like to kind of swing it around, like call it centrifuge machine sometimes? How about another way?
Could you like boil it so the water would evaporate out of it?
You could do that too, yeah. You could do a machine or boil it so the water goes out of it. Whether it's a machine or letting the water evaporate out, those are both physical ways of separating out the components of that particular mixture. So if you have a mixture, you should be able to separate back out your individual components again. Sometimes it's easier than others. Okay. So, all right. So we'll call this, you guys probably already have the answers here. Do you already have the answer? So I'll call this A and this B. Which one is heterogeneous?
Probably A. Wait.
Which one is heterogeneous, like different throughout?
B.
B? I'm liking it. Why is it B?
Because it looks like it's mixed.
It looks like it's not mixed. It looks like it's not the same throughout. Yep. How could you separate out into the components here? I think it'd be tedious, but
You can separate the colors.
yeah, that's what I was
Probably
thinking
all
too.
different sizes. So
Yeah,
you
I like the sizes.
can like sift through.
Sift
like the
through.
people that do gold mining and stuff, they probably have different densities, so you could do that.
Densities, I like that. All of that stuff would be just like physically undoing the mixture. Yeah, very good. Cool. So in this room is actually, looks like a place we want to be this morning, doesn't it? I would go. In this room actually is this mixture. I've circled it up there. Okay, so even though oxygen is important for animals to live, to breathe oxygen, most of the gas particles in here are nitrogen. So it's about 80% nitrogen, 20% oxygen. So that's a mixture. What do you think? Is it in this room with mostly nitrogen, some oxygen? How many people think it's a homogeneous mixture? Yeah, it's the same throughout. Exactly. Thank goodness it's the same throughout. And then this is kind of a closer look at seawater. So here are our cute little Mickey Mouse molecules. That's a water, H2O. So we have the oxygen, hydrogen, hydrogen. We talked about this the other day, where if you have, can't remember in what context, but if you have sodium chloride like this, okay, and if you have dissolved it in water, okay, like salt water, okay, then actually we can write on the other side NaCl, AQ. Do you remember that? So actually, this is sodium chloride dissolved. The other thing about sodium chloride is it's an example of an ionic compound. An electron is transferred. We'll be talking more about that. But these fat little green things, actually those are your Cl minuses. And these little blue things are your Na pluses. again, we'll be talking more about that. But, so I see three things, don't you? You see the water molecules, the Cl minuses, and the Na pluses. Think a homogeneous mixture? Probably. Yep. So mixtures can be homogeneous or heterogeneous. If it's well mixed, okay, it's the same throughout, we call it a homogeneous mixture. So actually, the term solution, you probably heard that before. We'll be talking more about that near the end of the semester. But solutions are a mixture where two or more pure substances have just been physically tossed together. So a solution is a mixture, it's a homogeneous mixture. And just to kind of give you a heads up with how this is going to go, there are a lot of S's when we talk about solutions. Here's my beaker, okay? A lot of times the thing that we're going to be, it's going to actually be actively doing the dissolving, a lot of times it's water, but we call that the solvent. Okay, and the little bit that you add to dissolve in your solvent is actually your solute. Solute. So we say the solution is equal to the solvent, which is in greater amount, plus the solution. Oh, plus the solute, sorry. Okay. And then this says, oops, this says if the solvent is water, then like with the ocean water, or with the salt water in the ocean, if the solvent is water, then we call that an aqueous solution. So, okay. So we'll take a look at these right quick. These will be due on Wednesday. And here's what they look like. Sometimes I look at them in class together and sometimes I don't. Especially the harder ones when we get going, I like to kind of look at them. So,
What did aqueous solution say?
what was the
Water is the solvent?
Waters, thank you. Oh, to your foot. That looks like it's got a good case.
It does. It's super blessed.
Oh, okay.
My phone actually fell out of my
Oh, is it okay? Must have a good case on it too.
Also, there's grass.
So these should be fine. Remember, the blue means that the answer's in the back of the book. You should do fine with this. What do you think about 34C? Okay, so water and gasoline. Water and gasoline. You think they don't mix, do they? Yeah. Yeah. So since they don't mix, probably heterogeneous. They're good. And then this is the other one. Oops, sorry. This is the other one. Come back here. And then this is the other one. So 35 and 36. Classify the substance as either being a pure substance or a mixture. And if it's a pure substance, you have to say if it's an element or compound. And if it's a mixture, you need to say if it's a homogeneous or a heterogeneous mixture. Some semesters, I think you'll do okay. Just kind of think through them. Do your best. All right. So let's go on to part 2. Okay. So we're going to play a little game. Okay. But this makes sense. Like, I don't care if it's chemistry or science or biology, or if you're talking about something in history, in order for you to communicate, it could be an idea or communicate what object you're dealing with. A lot of times you can kind of go back and forth and narrow it down as to what the properties of that object or that idea are. What are the properties of that object or that idea? So, if you've ever played the I'm thinking of game, you know, if you're like on a long trip and you're trying to make time fly, this is where one person thinks of an object, and the other people have to ask questions or get to ask questions about that object, and so the audience or whatever kind of piles on clues to what that object are. And if you've played that game, then when you kind of go back and forth with the person that knows the object, you are kind of asking properties about that object. Okay? So just for now, just worry about the first column. Okay? So we're going to go around the room. Okay? And I actually have an object up here that is underneath that little. Actually, it's a. What do you call it when you have little drape? It's curtain. It's like a little curtain thing I keep in my office. What?
Tarp.
What's it?
Like a valance? A tarp.
Yeah, it's kind
Like
of like a
the
balance.
short,
Yeah,
okay.
yeah, yeah. It's like a little short balance thing. Thank you. So it's hiding under there. So I thought of something, and we're gonna at least go once around the room, and then you can start guessing. Okay. I keep picking on Katie to start, but. So I have an object up here, and have you ever played the I'm Thinking of game? Okay. So you can ask anything about size, color, do you eat it, that sort of thing. You ask one question, and it has to be like a yes, no. So I have to be able to kind of say, yes, it is, or no, it's not.
Can you eat it?
Good question. So can you eat it? So here's where you put eat, question mark, and then you can put no next to it. That would have been a good idea, though. Bring something to share. No. Eat, no. Very good. Perfect. So what do you think, Alita?
Is it soft?
Is it soft? Yes. Soft, question mark? Yes. Okay, Caitlin. Let's see, you could, well,
Is it something that you use,
I think that's a valid question. I would say it's not really useful. So use, question mark, no. It's not one of those practical items. Okay. What do you think, Megan? What's your question?
Is it larger than the palm of your hand?
Let's see.
You need to go look.
It's about the size of the palm of your hand. So
Okay.
I'd say palm, question mark, yes. It's equal to.
Okay.
It's about the size of your palm of your hand. Good question. Let's do one more round before we even guess. Okay, Katie, what do you think? Questions?
Is it black?
No, it's not black. That's a good question. I'd say, and sometimes I'll give you a hint, it's just kind of the opposite. Very good. What do you think, Aletha?
Is it used for entertainment?
I'd say yes. Entertainment, question mark, yes. Okay, Caitlin,
Is it round
is it round?
or circular?
Right now it is, but it wouldn't have to be. So, is it round? Yes.
Got me all messed up now.
Okay, Megan. It's a hard one.
Well, I thought it was. malleable?
Yes, kind of like it.
Yeah.
Mhm. Is it malleable? Yes. Okay, so now we did 2 rounds, so now we're gonna go and you can ask a question and or if you want to guess what it is too, you can do that too. What do you think, Katie?
Is it just one color?
Yes. Just one color? Yes. Do you want to guess or are you gonna pass? I don't know if I could guess it right now. Alisa?
Do a lot of people use it or have it?
It's not very common. I'd say no. Common question mark, no. Did you want to guess? Or are you gonna just go ahead and,
Is it like putty?
is it like putty?
Yeah.
It's kind of like, it isn't putty, but it reminds me of putty, kind of. Okay? It doesn't stick together, the stuff I have. I don't know if we might have to. Caitlin, good question, good,
I
Good
would
guess,
say
though.
clay, but clay sticks together.
yeah,
Is it a stress ball?
no.
I don't know. Okay.
I got it on clearance in the Christmas section, if that helps, at Kohl's.
That doesn't help at all.
I will give you a property. Let's see, is it fake? Yes. Okay. Would it otherwise be cold? Yes. White.
Is it a fake snowball that lights up?
It's not. I'm gonna go ahead and give it to you. No, it's not a fake snowball.
Because my dog has one of those.
No, it's not a fake snowball, but it's this stuff that you get, and it looks like this. Okay, this is the powder. I'll let you pass that around.
So it's basically a fake snowball.
It is a fake snowball. Okay, but this is cool. I'll pass this around too. These are the same volumes of stuff. So you add a little bit of water, and this is all it's fake snow.
Can I touch it?
You can. It's
That's impeccable.
It's sodium polyacrylate. You know what it is, basically? It's like if you take diapers and you cut the diapers
I
out.
can feel it, yeah. It's like
Yeah.
the jelly stuff.
It's like,
I don't
well,
wanna
no,
touch it
it's
anymore.
just water. But it's the diaper stuff.
Like the stuff that, I don't know, have you ever been to the public pool? Like people let their kids swim in those, have you ever saw that when you're in the changing room?
Oh, yeah.
Well, yeah, because it will spread out and get like super gel.
The diaper stuff.
Like if it gets like, I don't know, over liquefied.
Well, because I'm gonna liquefy this one. So we'll go ahead and, so we'll over liquefy it and try, don't, find your happy place. Don't go to the. All right.
Fascinating.
Isn't that cool?
Can we just put a lot of fake snow in here? See how it gets clear? Stick your finger in it, it feels weird. I told you.
That's. Oh, gosh.
Yep, uh-huh.
There you go.
It's dense.
It is. So, how would you, speaking of, like,
How?
man, look how much that swelled up. I was gonna say, is there anything like,
Oh, I broke the stir stick.
oh, don't hurt yourself.
I didn't. It's okay. That's how dense it is at the bottom. I was trying to jab it, but okay, you might want this end.
Okay.
Hold on, I'm gonna turn it upside down for everyone.
Okay.
Don't do that.
Learn from me.
Stir it at the top.
So that is amazing.
That is super, yeah. That's bizarre.
Make checkers.
Anyway.
That's insane.
I like it.
You can't even like jab it all the way to the bottom. That's how like.
Very good.
I feel like that's not safe to put on a child.
So that stuff is not edible?
It is not edible, no,
What
no.
would happen if you
The
tried
real-
to eat it?
You'd poop gel.
Yeah, well, hopefully it's, hopefully it's done absorbing water, because if it's not, then actually that would interact with the water
That
in your
would
system.
suck.
You know those little things?
Don't they have like special pills like that like absorb the stuff that you eat?
Well, I don't know about that, but you know those things that say do not eat? You know, like, oh, you get them in a purse, okay? And it's
Okay,
like a
yeah.
little packet that says do not eat. They're usually like a desiccant, they're usually a drying agent. So, yeah, they say do not eat because it will interact with your,
I always throw those away, because like the stuff that's in like food and stuff, my family always eats that in a few days. It's supposed to keep stuff
yeah.
fresh.
Yeah, so it doesn't need it once you
says
buy
do
it, yeah.
not eat, not do not.
Makes me want to like take one of those, take scissors, open it up, and add water. You know what I'm saying? Because it's like it's a drying agent, so probably wouldn't do anything that cool. Well, let's do it. Let's put it on our bucket
I
list.
was thinking.
Okay.
Bag.
Okay. All right. So now, if you take that same list, there was a reason for your list. So your list, if you look at the last two columns, it says extensive and intensive. Okay, like the questions you asked to try to figure out what this was. Okay. You could ask anybody an intensive property question. And intensive means, and I usually say independent of amount. That's actually, as long as I've been kind of in physical science and teaching this, I always think of independent. And most of the questions you guys asked were intensive questions. Like, for instance, is it edible? That's independent of amount. Is it soft? The amount doesn't matter. Okay, is it useful? Now, to me, the fourth question there about the palm, okay, was the other sort of question. I mean, is it the size of your palm? That is an extensive property, okay? So examples of intensive properties are listed here. The temperature something melts at. It doesn't matter how much of that thing you have, it just matters that critical temperature that it happens to go from being a solid to a liquid. The color of something, who cares how much you have? It's white, right? Will it catch fire? Is it reactive? Will it conduct electricity or thermal energy? So extensive properties, so if you want to, on the fourth one, with your palm, go ahead and put a little check mark under extensive property, you could. Okay? So extensive properties do depend on amount. And usually if you're playing the I'm thinking of game, they're usually not extensive property questions. So what does depend upon amount? Well, here's a list. Okay? Mass depends upon amount, but mass is a characteristic mass is a property of matter. So for instance, I could just take, in this room, I could take one chair, which kind of has multiple colors, blue and silver, okay? Or over here, I could have a pile and stack 4 chairs. Okay, I kind of have 2 chunks of matter. I have this chunk of matter and this chunk of matter. Okay, the mass of those 2 are different. Okay, so mass depends upon amount. We'll talk more about moles later. Here's one for you. So again, back to amount. If I had 2 piles and I was going to burn paper, okay, so I'm going to burn 3 pieces of paper here, and over here I'm going to burn 100 pieces of paper. And you might be saying, well, 100 people, you know what I mean, 100 pieces of paper, it gets kind of, the logistics are an issue, because if you've ever been camping, you know that you want to get air to all of the material and everything. But assuming that I could go ahead and aerate it and I could do a full combustion, I would get a lot more heat given off during these 100 pieces of paper burning. Okay, so actually, yeah.
Just drench it in oil.
Drench it in oil.
Yes.
Just you bring your eyebrows off.
I don't like fire, so. Okay, oops. Okay, so to me, were there any other extensive properties you think asked that did depend upon amount? When you guys were nothing?
Is like things like round and malleable depend on amount?
No.
Okay.
But
I was just wondering.
All right. So then, I call this kind of yin and yang. Intensive properties, independent of amount, which is a lot of things. Extensive property does depend upon amount. And then these next two to go together. Physical property. Physical property and then chemical property. So those are the first two columns. Okay. So physical property is a really common property to ask. Most of what you guys asked probably was a physical property. Physical properties are things that you don't have to do any sort of reaction, any sort of chemical reaction. Okay? So, for example, color, you don't have to do any sort of chemical reaction to gauge the color. Mass, no sort of chemical reaction. Temperature, okay? So these are all physical properties. Table of physical properties. We compare that to, this is still physical property. Sometimes students will it'll get a little bit confusing when I talk about the temperature at what something melts is a physical property. The temperature at which something melts is a physical property. No sort of chemical reaction has to occur when you melt something. The distinction there, no sort of chemical reaction occurred is because after you melt it, if you let it cool down again, do you get that stuff back? And the answer is yes. You can heat it up, cool it down, heat it up, cool it down, and you still have the same stuff. Okay? So this is a good little example. Here we have two white powders. We have one you should consume for a headache, naphthalene, and one you should consume, don't consume naphthalene, for a headache, aspirin. And naphthalene actually is the thing that you use for like mothballs. It has this great odor, and I don't think you should consume it. Okay, but they're both white powders. And one boils at 82 degrees Celsius, that's the naphthalene, and aspirin boils at 135 degrees Celsius. So kind of a quick and dirty gauge to see which one's going to boil at 100 degrees Celsius is you could use boiling water, and that's actually what's been done here. So if we put both of them in a container that's 100 degrees Celsius, do you buy the one that boiled less than 100 degrees Celsius, it went ahead and melted? Boiled, I meant melted. And the one that melts you need to have temperatures above 100 degrees Celsius, it stayed a solid. Okay, so just kind of a quick and dirty. But the point here is we could go ahead and cool that, take those test tubes out and cool back down your naphthalene, and you're just going to have naphthalene back again. It's going to have this, and here it has the same chemical structure as it's melted as it does as it's solid. All right, so color is a physical property. Viscosity is a physical property. Let's see if this one comes up. It should. Occur in order for you to measure it, in order for you to gauge it. So that's why I kind of thought with Megan's question, is it edible? To me, that is a chemical property because some sort of chemistry is going to happen within your body. You'll either live or die. So, yeah. Yep, so chemical property needs some sort of chemical reaction to gauge it. So up here, when I had the pieces of paper, I had 10 pieces or 3 and 100 pieces of paper. I mean, the fact that paper will burn, and we know if you want it to burn, we could use oil or something to get it to burn, but we know it's combustible. So that is, to measure if it's combustible or not. You would have to do a chemical reaction. Okay. We know we have a chemical reaction because after you burn it, it doesn't look like paper anymore. Okay, something different. You have something different, which is just kind of ashes. So that's combustibility is an example of a chemical property. Okay, speaking of chemical properties, we have, I don't think we have lithium. We have sodium, though, in the chem lab. And just to kind of show you what these look like, I think you should do fine. Remember, the blue ones are, you have the answers in the back of your book. So here you're supposed to say, are these properties physical or chemical? And then the next one. Oh, I like this. This is new for this edition. 39 gives you a deal with ripening agent for bananas and asks you, are these physical or chemical properties? So I think you should do fine. All right, cool. We will see you